Hi friends, welcome back to a new session. In this session, we are going to discuss about auto transformer, which is one of the most important topics for GATE point of view or engineering service examination point of view also. Okay, auto transformer. Auto transformer. See, we are already seen two-in transformer. In two-in transformer, we were having two windings. They are electrically isolated, but they are magnetically coupled with each other. Power transfers by using only induction principle. In auto transformer, we are having only one winding. In auto transformer, we are having only one winding. I'm not showing here core. I'm just showing only winding here. I'm just showing only winding. I'm having only one winding. That is nothing but high voltage winding. High voltage winding. In auto transformer consists only one winding, that is high voltage winding. A, B, C. Let me give terminal names A, B, C like that. And so let me take. I said, are you in auto transformer? I'll be having only one winding, nothing but high voltage winding. Part of the high voltage winding, this part I can say. Part of the high voltage winding, this portion. Part of the high voltage winding is common to high voltage winding and low voltage winding. See, this portion can be taken as the low voltage winding. This portion is common to low voltage winding and high voltage winding. So simply I can say that auto transformer means auto transformer consists only one winding, that is high voltage winding, and part of high voltage winding, some portion of high voltage winding is common to high voltage winding, high voltage section, and I can say low voltage winding section. Okay, I can take this AC can be taken as high voltage winding. BC can be taken as low voltage winding. What is the other name for this BC? I can say BC is common to both LV and HV. So I can take BC as low voltage winding, or I can say common winding. And what about AB? Can be called as series winding. Observe guys clearly, here I am having only one winding. AC is high voltage winding, and this is nothing but across AC voltage is about VH high voltage, and let me show it as current IH here. This VL low voltage. Let me show current IL. I told you it is it is auto transformer having high voltage this side, low voltage this side. Means I can take it as a step down auto transformer. Step down means what? Here low voltage, here high voltage. Here high voltage means, let me take, if I take dot here in this section, that means let me take a dot as plus, minus. In this section, where I have to keep dot? Obviously here only, no? Because once again plus, minus. Plus, minus, then only voltage will add up here, more voltage. Okay. And here one thing you have to understand is very important. Please try to concentrate here. I'm just keeping dots like this. Dot I just kept like this. If I take dot here, plus, minus, non-dot terminal can be taken as minus here. And it is a high voltage section, therefore voltage should be add up. Therefore plus, minus, then only voltage will add up. So I should keep dot here, dot. Okay. And here we discussed already in two-winding transformer to satisfy Lenz's law. If current enters the dot in one coil, in another coil current has to leave from the dot. Okay, that's very important. So please try to remember that point. That will be useful for our for solving some previous questions also. See, in this case, I can show this IH as high voltage current, IL can be called as low voltage current, and here BC is nothing but low voltage winding or common winding, and current through this BC can be called as I, nothing but common winding current. So please tell me what might be the direction of your I here. That is very important. Please, you have to confirm the direction of positive I current. Direction of positive I current. See here, IH is coming like this. It is entering at the dot here. It is entering, right? Observe clearly. This IH is coming like this, and it is entering here, dot. Therefore, from this dot, current has to leave. So obviously, what the direction of I has to leave here means, so direction should be like this, upwards. Then only it is entering at non-dotted, it is leaving from the dot. So like this, you have to decide direction of common winding current. Is it clear? Direction of common winding direction. How I'm just justifying means, if current enters the dot here, current has to leave from this dot. So please try to refer to in transformer topic. So therefore, this is direction of your I, right? Now what about this IL? IL equal to IH plus I. IH plus I. This is value of your IH. Now, though I'm having only one winding, AC is the high voltage winding here. Part of the high voltage winding BC is common to both low voltage and high voltage. So observe clearly, if you consider this as two sections, this one section, this one another section, series winding section, common winding section. These two sections are electrically connected, and these two sections are magnetically also coupled. Therefore, in auto transformer, power transfers not only by induction principle but also by conduction principle. That we have to remember. Let me write that point here. In auto transformer, power transfers by using induction principle, and conduction principle. Okay. Now tell me here, if you want a rating of auto transformer, or I can call it as the rating of auto transformer can be called as S auto or S out. S auto or S out equal to VL into IL. So VL into IL means how much? I plus IH. So this will be equal to VL into I plus VL into IH. From this I can write this can be taken as S induction power plus S conduction power. So there is S auto or S out is equals to S induction plus S conduction. Okay. So you just try to remember only one point here. In auto transformer, power transfers by using induction principle and conduction principle. And tell me guys, in auto transformer, K is nothing but transformation ratio. K is equals to formula. Always I'm saying, always step down or step up. You can take any one. K is always equals to VL by VH, that equal to NL by NH. Why? Number of turns directly proportional to voltage. Therefore, VL by VH equals NL by NH is equals to IH by IL. Can you please tell me this K value is less than 1 or greater than 1? It's always less than 1. Why? Since you know VL, L means what I'm saying? You are saying L means low, H means high. That means what? VL is less than VH. NL is less than NH. But don't write IL less than IH. It is IL greater than IH. See clearly? IL equal to IH plus something. See, transformer is a constant power device. If voltage is lesser, current will be more. That means VL is less than VH, already know. Okay, NL is less than NH and IL will be greater than IH. If voltage is less in low voltage side, in low voltage current will be more. IL is greater than IH. See, always low value by high value, because VL is less, no. Low value by high value less than 1. Low value high value less than 1. Among IH and IL, which value is less? IH is less. Low value by high value less than 1. So try to remember this K value is equal to how much? VL by VH, NL by NH, IH by L, which is always less than 1. And here, see some derivation will be here. It's not necessary. Directly just remember, because GATE point of view. So please try to remember. S induction is equals to formula S out. What is the other name for S out? I told here S out or S auto. S out into 1 minus K. S conduction is equals to S out into K. These two formulas, please try to remember, where S out means rating of auto transformer, K means transformation ratio is always VL by VH is always less than 1. Is always less than 1. Is it clear? Now, here comparison. This is very important. Comparison of what? And let me compare auto transformer with the two-winding transformer. So you are having some formulas here. Those are important here. First one. Before that, you should remember one thing. See, I told you K is less than 1. That means 1 minus K will be less than 1 or greater than 1? Less than 1 only. If K is less than 1, you can take any value. You can substitute any value. 1 minus that value, less than 1 only. 1 by 1 minus K value, greater than 1. Just try to remember this also, which will be useful for us. Now tell me. S auto transformer, or I can say S out. See, nomenclature S auto or S out, whatever. S auto by S two winding is equals to K. 1 by 1 minus K derivation is there. 1 by 1 minus K. 1 by 1 minus K means what? Greater than 1. Therefore, S auto transformer is greater than S two-winding transformer. Means what? If I'm having two-winding transformer, if I modify same two-winding transformer as an auto transformer, then rating of auto transformer will be greater than rating of two-winding transformer. That's a very important conclusion here. Please try to remember this formula. Very important. This relation also. Next, second one. Per unit losses of auto transformer divided by per unit losses of two winding transformer is equal to, what is the formula? Very simple. Total losses. TL means what here? Total loss of auto transformer divided by the rating of auto transformer. This is the formula of per unit losses. By total loss of two-winding transformer divided by rating of two-winding transformer. Okay, here I should give a note here. See, suppose if I use one two-winding transformer, if I modify the two-winding transformer as an auto transformer, okay, you have to remember one small note here. Total loss of auto transformer and total loss of two-winding transformer will be approximately equal. You please try to remember this as a note. Approximately, approx, not exactly, approximately the same. So I can write here total loss of auto transformer is approximately equals to total loss of two winding transformer. Transformer. So this is a note. Okay. So from this, if these are equal, okay, it becomes what? S two winding by S auto is equals to the value 1 minus K is less than 1. Means per unit loss auto transformer will be less than, therefore per unit losses of auto transformer will be less than per unit losses of two winding transformer. This is the conclusion here. Okay. This second observation is also important. Next, third one. See, Z per unit of auto transformer by Z per unit of two winding transformer is equals to 1 minus K less than 1. And here also one more thing. In auto transformer, leakage flux will be less compared with your two-winding transformer. I had given you definition for leakage flux, all those things in two-winding transformer. Please try to refer that. So leakage flux will be less in auto transformer. So leakage reactance will be less in auto transformer. So voltage regulation will be less in auto transformer. So I can write here voltage regulation. VR means what? Voltage regulation. Voltage regulation. Voltage regulation auto transformer by voltage regulation of two-winding transformer. I said it is less in auto transformer. So obviously 1 minus K is the value less than 1. Less than 1. Okay. Next, fifth observation. This is fifth observation. Fifth observation. Short circuit currents, SC currents. Short circuit currents of auto transformer by short circuit currents of two-winding transformer is equals to. It's very simple. You know, two-winding transformer, their windings are electrically isolated but magnetically coupled. But here, if you see this section, they are electrically connected. So there are a lot of reasons for having more short circuit currents here. So SC currents of auto transformer, SC currents will be more. More means here value greater than 1 should be there. Greater than 1 means 1 by 1 minus K is greater than 1. So SC currents of auto transformer will be more than SC currents of two-winding transformer. Okay. So note it down. So first note of this one. We have to further, one more comparison is there. That's all complete this. Yes. Next, let me explain sixth point. Because of that sixth point only, auto transformer, I can say it's very famous because of this sixth point which we are going to discuss. See, sixth point. Weight of copper of auto transformer divided by weight of copper of two-end transformer is equals to, getting 1 minus k is less than 1. That means what? Weight of copper of auto transformer, weight of copper of two-end equals to less than 1 means, so obviously weight of the copper will be less in auto transformer than two-end transformer, right? So tell me here, saving of copper is equals to saving of copper in auto transformer. If I use auto transformer, when compared with the two-end transformer, copper is saved here. How much copper is saved means, tell me where requirement of copper is more, two-end transformer, right? So I can write simply here, saving of copper equals to weight of copper of two winding minus weight of copper of auto transformer. So weight of copper of two winding minus, what is the formula of weight of copper of auto transformer in terms of two winding weight? Weight of copper of auto equals to 1 minus k times of weight of copper of two winding. So here you'll get k times weight of copper of two winding. So this is the saving of copper in saving of copper in auto transformer. Is equals to how much? Weight of k times weight of copper of two winding. It's purely depending on a k value. Suppose if you keep k value equals 0.1, if you keep k value equals 0.1, when compared with the two-end transformer copper, 10% copper will be saved in auto transformer. So 10% copper is saved. Suppose if you keep k equals 0.5, 50% copper is saved. If k equals to 0.8, 80% of copper is saved. Okay, if you compare with your two winding. See, so here for this k value, one breakdown limit is there, from break-in point is there. Okay, so I can give that point here. Just remember this as a note, it's very important. If k is greater than or equal to 33.3%, this 33.3% is about break-even point. Okay, above which auto transfer is feasible. That means, you know, auto transfer. If I use auto transformer, if k value is greater than or equal to 33.3%, so it is more economical because saving of copper is more beyond this limit. So it is feasible. I can say the auto transformer can be feasible. So if k is greater than or equal to 33.3%, auto transformer is feasible. That means I can use this auto transformer because so many advantage will be there in auto transformer when compared with the two-end transformer. Suppose if k is less than 33.3%, auto transformer is not feasible. This 33.3% can be called as break-even point. Okay, note on this. Yeah. Tell me in this example, suppose you are having a substation like this. 220 kV by 130 kV substation is there. Tell me, can I use auto transformer? That means if I use auto transformer, Tell me first of all whether we can use auto transformer or not. Means tell me where we can use auto transformer. See, observe clearly here. I can give a note here. If K is 0.1, 10% copper saved. 0.8, 80% copper saved. That means I can give a note here. What is that? Auto transformer is more economical. Auto transformer is more economical. Auto transformer is more economical when K reaches near to unity. Auto transfer is more economical when when transformation ratio K approaches, or I can say reaches nearer to unity. Now tell me here, I mean that is the point I had given here, and here I given one more point also, break-even point also I had given. So depending on the this break-even point, I can decide whether auto transfer can be feasible or not feasible. If it is greater than or equal to 33.3%, it is feasible. If it is less than 33.3%, not feasible. Now tell me, so what is the K value here? I told you K means always low voltage by high voltage. So 132 by 220 gives how much? 132 by 220 it gives so 0.6, that is I can say 60%. 60% is greater than 33.3%. So I can say therefore auto transformer can be used. It is feasible. Now similarly tell me one more thing I'll ask you. 220 kV by 33.3 kV. 220 kV by 33.3 kV. Tell me here K value. 33.3 low voltage by high voltage 220. How much? K value equals you are getting it is approximately 15%, which is less than 33.3%. So obviously auto transformer cannot be used. Next, tell me one more thing. 33 kV by 11 kV. 33 kV by 11 kV. In this case, K value how much? 11 by 33. How much? So 1 by 3. Nothing but I will get exactly, that is K equals to 33.3%. I told you if K is greater than or equal to 33.3%, auto transformer is feasible. Therefore, I can say here auto transformer can be used. So like this, depending on your K value, you can decide auto transformer can be used or not used. When auto transformer can be used? When K value is greater than or equal to 33.3%, their saving of copper will be more. So therefore they are more economical. So in place of 2-in transformer, we will use auto transformer. Is it clear? So like this, you can decide for this 1, 2, 3 examples. Okay, make it fast. Now tell me, can I use? Let me give a note here. In interconnected power system, let me write here. In interconnected power system, okay. So you might have seen where center grid is connected to state grid. Okay, in interconnected power system where center grid is connected to state grid. Example, I mean 400 kV by 220 kV. Obvious auto transfer will be feasible. If you want, you can check 220 by 400 kV. Just substitute. You'll get K value will be greater than or equal to 33.3%. So auto transformer can be used. Right. Now tell me what are the advantages of using auto transformers? We already discussed it, but anyway, just try to recollect once again. What are the advantages of using auto transformers? Advantages because of using auto transformers. Number one, tell me. We discussed already rating of auto transformer will be more than the rating of two-end transformer, because in auto transformer power transfers by using induction principle and conduction principle. So rating increases. Whenever rating increases, obviously, so efficiency also will increase. First one, let me write advantage of auto transformer, rating increases. First one. Second one, I can say that efficiency increases. Third one, I told you, leakage flux will be less here, leakage reactance will be less here, so voltage drop will be less here, voltage regulation will be less here, voltage regulation will be less here, less here. Next, tell me what is the one more thing. I told you I'm using only one high voltage one winding, that is high voltage winding. You might have seen in two-end transformer we are using high voltage winding and low voltage winding. There I need some insulation between core and the low voltage, and I need insulation between low voltage and high voltage also. But here I am having only one high voltage, one winding, nothing but high voltage winding. So I require insulation only between core and high voltage winding. So requirement of insulation requirement is less. Insulation requirement is less. Insulation requirement is less. Why? Since insulation requires between core and high voltage winding only. Core and high voltage winding only. Okay. But obviously, you know, whenever insulation requirement is less, thickness of insulation will reduce, size reduces, okay, cost reduces, it's everything, no, okay, just note down. Size reduces, cost reduces, those things, okay. Next, so one more thing is there here, advantage. What is that? Very, very important. Because of that only, your auto transfer has become very famous. What is it? What I told? Sixth point. Weight of copper will be less. Requirement of copper is less. Requirement of copper is less. Requirement of copper is less here. So rating increases, efficiency increases, voltage regulation less, insulation requirement is less, size reduces, cost reduces, requirement of copper is less. Next, tell me what is the disadvantage here? What is the disadvantage? I'm saying, I'm asking disadvantage. See, I already told you, because this series winding and a common winding, they are electrically connected. There are more short circuit currents here. Okay, so obvious number one, I can say short circuit currents. Short circuit currents are more. Here. Number two. See guys, suppose if it is a example, let me take a 400 kV and it is a 220 kV. Like example, let me take 400 kV and 220 kV. What is the main problem here? If suppose if I use auto transformer as an step down transformer, 400 kV by 220 kV example I'm saying, if common winding is open circuited because of some problem, if common winding is open circuited because of something, if common winding is open circuited, at that you tell me, entire high voltage will appear across this load. 400 kV will appear here. So entire high voltage will appear across this load, which is dangerous to the equipment and also to the person who is operating there. So let me write here in second point, in step down auto transformer, if common winding is open circuited, entire high voltage appears across load, which is danger to the person, who is operating, and also to the equipment, Okay, not only. So this is about advantages and disadvantages. And can you please tell me what are the applications where we are using this auto transformer? See, I told you already in interconnect power system. So let me write used in interconnected power system. Used in interconnected power system. Second one. See, if you see in AC feeders, if voltage drop occurs, I'll use auto transformer to boost up the voltage. That means you can use it as a booster. Auto transformer can be used as booster in AC feeders to boost up the voltage, to compensate the voltage drop. Okay. And third one, it is used for starting synchronous motors. It is used for starting synchronous motors and induction motor. It is used for starting synchronous motor and induction motor. Okay. And one more thing, you can use this auto transformer as an variac in a laboratories for getting variable voltage. Used as variac. It is used as variac. For getting variable voltage. Where in a laboratories. Okay. It's not. Next, see, suppose if so this information, okay, and next topic, nothing but relation of auto transformer from two-end transformer. See, gate point of view questions, they'll give you two-end transformer, they'll ask you to modify it as auto transformer, and they'll ask you efficiency auto transformer, or they may ask you rating of auto transformer, all those things. Okay. So realization of auto transformer from two winding transformer. Example, let me take two winding transformer like this. Two winding transformer. I'll take one example. Two winding transformer like this. So 3300 volts, 3300 volts by 220 volts 33 kVA transformer. 33 kVA transformer I'll take. This is what I can say. Two winding transformer just I have taken here. 33 kVA, sorry, 3300 volts by 220 volts, 33 kVA transformer. Okay. And they'll ask you to modify this as an auto transformer. Okay. And in the meanwhile, you have to remember one thing here. Yeah, before realizing this two-end transformer as an auto transformer, tell me what is the current flowing through this 3300 volts winding. Very simple. 33 kVA, no? 33 kVA, 33 into 10 cube by 3300. Okay. How much you'll get? You'll get 100 amperes. Sorry. Double three, no? Double three, I can say this one. Double three 10 cube divided by 3300. You'll get 10 amperes, sorry, 10 amperes. And what is the current flowing through 220 volts? So double three into 10 cube by 220. If you do that, you'll get 150 amperes. How much? 150 amperes. 150 amperes. So this information is necessary for us. Now let us start. So from this, if you want to redraw auto transformer, that too, first case I need step up auto transformer. How can you get step up transformer? By using a series aiding polarity. And they'll give hint for you. They'll ask you in the question itself, use 3300 voltage, they make you like this, 3300 volts as source, like that they make you. So in our example, let me take a 3300 volts as source. Okay, now tell me, if I take 3300 volts as a source, and if you want to convert this two-end transformer as an auto transformer, that to step up, means if I take input 3300, what might be the output voltage? The same two windings only you have to use in auto transformer. You cannot use any extra winding. Okay, so 3300 volts plus 220. That is your output voltage of your step-up transformer. Okay, so first of all, how you are going to convert? So let me draw two-winding transformer once again. This is 3300 volts winding having a dot here, and this is 220 volts having a dot here. And he said you have to use the 3300 volts as source. That means see, like this, plus minus. We are having a plus minus 3300 volts here, and if you want 3300 volts plus 220 output voltage here. Suppose if I connect this 220 here, that means what? To this dot, if I connect a non-dot of your 220 volts, like example like this, minus plus. Dot means in my example plus. Okay, plus. So if I connect this here, means what? Non-dot should be connected to dot. Means I can say minus should be connected to plus. So then this is what 220 volts. Then you get output voltage how much? You can say 35. If you go for a 220 volts, no, 35 220. 3520. 3520 volts. 3520 volts. Okay. So this I want. For that, what you have to do? That means what? Observe clearly. This is plus minus. This plus minus here it is it. And to this plus means to this dot, we should be connected 220 volts minus 220 volts non-dot means this one. So it should go like this. That's it. Okay, I can redraw once again for your understanding. See, first I am writing 3300 volts winding, 3300 volt voltage winding. Here dot is there. Dot means indirectly I can say it as a plus, here minus. and to this dot, to this plus, which is connected minus of your 220. Okay, so minus means I can say that the minus, and here dot is there, plus. This is 220 volts point. Observe clearly, plus minus, to this plus, minus is there here. This inlet you can under plus, dot means plus, this is non-dot, I mean non-dot means minus. To this plus, minus is connected. To this plus, minus is connected, that's it. Okay, now this is what I can say output voltage. Now tell me, plus minus plus minus. This is 220 volts, this is 3300 volts. 220 3300. How much? 3520. 3520 volts. So I can take this 3300 as VL. I can take this 3520 as a VH. Step up transformer. Step up transformer. Very simple. Step up transformer, right? So here this is what I can say IL current, and this is what I can say IH current. Observe guys, I told you one thing. So if you want to decide the direction of common winding current, what I said, suppose if you see IH value, it is coming like this. That means it is the leaving dot. That means I value, common winding current has to enter at the dot, has to enter at the dot. That means it has to come like this, downwards. Then only it can enter here. Okay. Is it clear? How I decide direction of common winding current means I told you, just like two-winding transformer, if current enters the dot in one coil, current has to leave the dot another coil. Here I know is the direction of IH means that it is going to the load, it is leaving the dot. So obviously in this winding current has to enter. So direction of common winding should be downwards. Then only it will enter. I can say that it is entering a dot. Is it clear? Now, one thing you have to understand. It's a very, very important point which I am just going to say. Current flowing through 3300 winding is 10 amperes. Current flowing through 220 volts is 150 amperes if it was two-winding transformer. After modifying also, current flowing through that particular windings will be same. That means this is 3300 volts winding when it was two-winding transformer. Now tell me here, what is the 3300 volts winding? This one. What is the current flowing through this 3300 volts? I. Previously, what is the current flowing 3300? 10 amperes. Now also 10 amperes. Very important. Current flowing through particular windings will be same in a two-winding transformer as well as in a auto transformer also. Now, see current flowing through 220 volts, how much here? 150 amperes. Where is 220 volts here? This one. What is the current flowing through 220 volts? This one. I mean nothing but IH. Previously, what is the current flowing through 220 volts? 150. Now also 150 amperes to this 220 volts. Is it clear? Now IL becomes how much? This is the total current going to your 0000 and 220. Sum of this I and IH. How much? 160 amperes. Is it clear? Now see what is this, like this you have to convert. Okay, you have to modify two-winding transformer as an auto transformer, that to step up transformer. Is it clear? Okay. Next, suppose this is regarding auto transformer. How I am just modifying auto transformer from two-winding transformer, that to step up transformer. Now please tell me, auto transformer only, that I'm just going for step down auto transformer. Step down auto transformer means what? Series subtractive polarity. Series subtractive polarity. Series subtracting polarity. And I'll give hint once again. Take 3300 volts as source. Once again, this two winding, please try to draw once again here. Please try to draw once again. This is 3300 volts winding. This is 220 volts winding. Dot here, 3300 volts, and here it is 220 volts. 2 volts. I just said that you have to use 3300 as source. So plus minus 3300 volts as I'm just taking it as a source. Step down means 3300 minus 220. It's not adding, it's a subtracting, right? Minus 220, you'll get around 3080. 3080 you'll get 3080. That means here plus minus is there, so definitely here plus should be there and minus should be there. This is what I can say 220 volts winding, minus plus plus minus. Then you'll get here 3080. 3080. 3080. Is it clear? Very simple thing. Previously plus minus. If you want 3520, plus minus here plus minus plus minus, then only these two will add up. You'll get step up transformer. I'm just saying here 0000 volt voltage here a source is there. You need step down transformer. Therefore 0000 volts minus 220 3080 should be there. That means to this plus should be connected, not minus. So that means what? This is plus of your 0000. So it should be connected to plus of 220. This is 220 volts there. Okay. So now how can you, this plus of 220 should be connected to this. That's it. Very simple. Okay. Now please try to redraw once again for understanding purpose. So I'm just going to erase this one. Yeah. Now this is what 3300 volt is. They say that dot is there. Here 220 volts winding means this is dot. This dot is connected to dot once again. That means dot here. You know dot means I can take it as plus minus plus minus. This is what 3300 volt, and what of this winding? 220 volts, and what about here voltage? Minus plus plus minus. 220 here 0000. So what is the value? 3080 volts. So input is 3300, output is 3080. That means obviously it is stepped down transformer. I can take it as this is the low voltage, no? This is 0000, this is 3080. Previously 0000, 3520. Therefore VL, VH. Now it is stepped down. So I can take it as VH and it's VL. I think now you can tell answer. This is the direction of your IH. This is obviously this current means VL means this one means what is the current coming here? IL. IL current will go to the load. This direction everybody knows that. IH, IL everybody knows that. Now tell me how can you decide direction of common winding current? By this time only you should be able to understand. Tell me how can you decide direction of common winding current here? Observe this IL from this dot, it is entering or leaving. Direction of IL is like this. That means it is entering a dot and leaving at the dot. It is entering at the, it is entering, it is entering, it is entering. It is IL is entering a dot going like this. Therefore I, whatever current I is there, it has to leave the dot. Leave the dot. That means your direction should be bottom to top. Suppose if you draw top to bottom, that is wrong because it is entering a dot. But what you want, current has to leave this dot because already current entered one dot. So definitely current has to leave the dot in another coil. So this is direction of I. So tell me what is the current flowing to 220? 150. What is the current flowing to 220? Once again here also 150 will be there. Current flowing through 3300, 10 amperes. Current flowing 3300. So many people will be having confusion. Some people they may take a 3300 volts winding current means they will take IH. Don't take IH. Current flowing 3300 means I, not IH. So how much this value? 10. Is it clear? Now tell me, what about this current? What about this IH value? Tell me what about this IH value? Very simple. See, total current 150 amperes is coming to the load. Here 10 amperes is coming. So what might be this IH value? 140. Okay, 140 amperes. 140 amperes. 140 amperes. Okay, like this I can realize auto transform from this 2-winding transformer. Okay, here you need to understand one important thing here. So before if you want to solve some previous gate questions, 2 marks point of view questions, this information is necessary. At the same time, in addition to this, I need to give some points, I need to give some notes. Okay, so by understanding those notes only, you can able to solve any question in your auto transform. Okay, that I'll continue in the next session. In this session, what is the conclusion? In the whatever the notes I'm just going to give in the next session, in that one important note already I told this: current flowing through particular windings will be same after modifying it as an auto transformer also. Previously 3300 volts winding current 10 amperes. After modifying it as auto transformer also, current through 3300 is same only. Okay, and one more thing, as I told you, total loss of auto transformer and 2-winding transformer can be taken approximately equal. That's what second note. This I'm just going to dictate in the next session. Okay, and okay, you observe one more thing, one more note here. Suppose it is a step up auto transformer, right? Here, if I connect one voltmeter here, if I connect some voltmeter here, output here also, let me have some voltmeter here. So for measuring output voltage, if I connect some voltmeter here, one terminal is connected to dotted, another terminal is connected to non-dotted. It can be used as step up auto transformer. If one terminal is connected to non-dotted, another terminal also connected to non-dotted, that can be used as a step down auto transformer. Okay, that is also an important observation. So in addition to these points, I'll give some more points in the next session. First of all, note on this.